Afternoon or good morning, and welcome to today's Libelle webcast, Turnkey Disaster Recovery with Libelle, Innovative, Simplified and Complete. My name is Frank Küppers. I am Alliance Manager for Libelle LLC, and I'm your host today. And together with me, we have Bernd Bayer. Bernd is our VP of Libelle LLC, and Bernd will also guide you through the main part of the presentation for today. I will just do the introduction and then I will hand over to Bernd. So welcome, and I hope you will enjoy this webcast. Before we start, we want to show you some guidelines how you can interact with us. Of course, your phone lines are muted, so you or we cannot hear you, but I hope you can hear us okay. The audio is either transmitted via the telephone, or you can also use your speakers from your laptop or your mobile device. And to interact with us, you can use the questions feature in the GoToWebinar control panel. And when you click on this question box, you can actually type in questions during the webinar, and we will then later on during the Q&A session be able to answer those questions, hopefully. So this is how you can interact with us. For those people that can't make it for today, maybe some of your colleagues that are unable to join, we will also record this webinar and send a link out with the recording later on. So please feel free to use that question and answer session or this question feature, and then we will try to answer those questions as good as we can. So today's team, again, my name is Frank Küppers. Bernd is our presenter. He is Solution Architect and Vice President for Libelle LLC. And we would like to get started now. So looking at the agenda for today, the first thing we're going to cover is briefly introducing you to our company. Those of you that don't know Libelle too good, then we will touch base on some company highlights, talk about alliances, customers, and also some installation profiles we usually see when we install our software. Then I will hand over to Bernd. Bernd will continue with considerations on how and what to scope for when you want to install DR tools in your landscape. Bernd will then also touch base on how Libelle approaches complete DR landscapes, how we will handle the failover of complete landscapes from main production side to the disaster recovery side, and also vice versa. And then during a live demonstration, Bernd will show you the Libelle software, the GUI, and also different configurations for different operating systems and databases all in one GUI. And we're really excited that we are able to show you such a big landscape, and you will also be quite excited, I think, when you see the setup that we prepared for today. And at the end, of course, we will touch base for the question and answers and answer your questions. So looking at Libelle, at the company highlights, Libelle is a German company founded in 1994, and the headquarters is in Stuttgart in Germany, which is not far away from Walldorf, where SAP is located. And in the US, we have an office in Atlanta, actually already since 2004, when we started to distribute our Libelle tools also in the US, and since 2009, the office really is a Libelle office in Atlanta. We have two different divisions within our Libelle AG. One is dealing with disaster recovery tools. This is the topic for today's webcast. And another division is handling system copy automation and other SAP-related automation tools. This is something we will touch base on tomorrow. At the same time, there is another webcast specifically considering the system copy automation tool from Libelle. And if you have not registered yet, please feel free to do so. You should also have received invitations, emails that we have sent out previously. So make sure not miss that webcast for tomorrow as well. Of course, when we look at disaster recovery, we have developed our disaster recovery tool since 1994. The first product that we brought out was supporting Oracle at that time. Later on then, during the early 2000s, we also added support for DB2, Microsoft SQL Server, and MaxDB databases. plus not only databases that we support, but also flat files. And we also looked into platform consolidations in 2005 and beyond. Later on, last year actually, we started also, as SAP expanded their support for Sybase databases, we also support now Sybase platforms in our tool, and we are currently working also on the SAP HANA database support. We have more than 1,200 installations worldwide at more than 400 customers. Actually, I think 450 is now the more correct number. And this is really going very well with our Libelle Business Shadow tool. This is the disaster recovery tool that is handling the DR failover. The system copy automation tool was launched in 2011, and with that tool we are really able to dramatically speed up the whole refresh process for your SAP system. So if you want to refresh your queue or dev boxes with data from production, this can be optimized and automated, and that's a topic for tomorrow as well. For that tool, we already have more than 300 installations at more than 100 customers worldwide. Other areas that we also are quite strong, that's our belief, we are established SAP consulting practice, and we have more software tools which also will be announced pretty soon. There is something new coming up, so you can be very excited. We have not yet been able to get the allowance to talk about it publicly, but there is some changes in our Libelle organization, and you will notice, or you will get information very, very soon. So stay tuned. Okay, we have very high commitments also to our partners and to quality. We are certified and are actively maintaining our partnerships with key industry players. You see some company names on the right of that chart. And furthermore, we also are very proud that we are ISO certified according to ISO 9001 version 2000. This is a quality certification, also very important to our company. When we look at our customers and typical installation profiles that we see, we have more than 450 customers, and of those customers, we have very, very big customers. We have 8 of the global Fortune 500 companies that are using our software, and those customers are really huge customers with more than 1 billion annual revenue. We have more than 40% customers also in public companies, publicly owned companies, but of course also the small and medium business market is interesting for us. We are serving customers from very small sizes, 30 million up to 300 million US dollar annual revenue. This is our SMB typical customer base. For the installation profiles, we support customers on all different databases that also are supported, for instance, by SAP, which are Oracle, Microsoft SQL Server, MaxDB, DB2, Sybase, and flat file mirrors. But of course, customers can also use those databases and can use our tools in combination with those databases without being an SAP customer. So also for standalone Oracle applications, our tool is very useful, so as also for the other database tools as well. From a platform point of view, we support all different kind of Unix, Linux flavors, and also of course Linux and Windows, and also OS 400 operating systems. Typical implementations range from a couple of 10, 20 gigabytes, small databases, up to very big landscapes and single databases with more than 50 terabytes in one database. Majority of our customers, 70 to 80%, are actually SAP customers, so these are systems in SAP landscapes. With this brief overview, I would like to hand over to Bernd Bayer, and Bernd will now continue the presentation from his point of view. Thank you very much for your attention and enjoy the webinar.
Awesome. And Frank, thank you very much for the introduction. My name is Bernd Bayer. As Frank introduced me, I am a solution architect. I'm also vice president of Libelle in the United States. I've been doing this kind of business for many, many years with Libelle. I started my career with Libelle in Germany until they sent me to the United States. And I'm looking forward to spending the next 45 minutes with you going through disaster recovery architectures and the Libelle software. And again, I appreciate your time a lot. I know nowadays it's difficult to even cut out 60 minutes out of busy schedules. And I hope Frank and we're going to make it worth your time and give you good information on how to improve your disaster recovery architecture or how to build it from scratch. I have 3 aspects I want to cover: a theoretical introduction on disaster recovery architecture, the Libelle tool itself, how we approach DR, and then of course the live demonstration. And for the live demo, we really worked hard on setting up a lot of systems to show you. So it's going to be exciting, showing you the graphical user interface front end, and there's more than 20 different replications we are looking at, different platforms. So it's going to be exciting. With that, I want to get started. First of all, kind of positioning what we are talking about. And the first item which is important for us is to distinguish between high availability and disaster recovery. Oftentimes it gets mixed up. Sometimes it is kind of put into the same project but still separated. But I want everybody to mentally separate high availability from disaster recovery, because that's also impacting the parameters of your project. A high availability scenario, which is the local failover, you are talking 0 data loss, you are talking immediate failover, and you can do that because you're typically in the same data center and just flip a cluster from A to B. In disaster recovery, we're always talking very large distances, so we always have to consider potential data loss, recovery time. It's not possible to switch over a complete data center with 60 systems within fractions of a second. We've got to be realistic setting this up. I mean, you can set up this to minimize those points, but high availability is easy. Disaster recovery is more challenging in terms of recovery points and recovery times. And then the business continuity side. Disaster recovery is a subset of business continuity, and we as Libelle, we focus on the technical aspects of disaster recovery. We are not doing any business continuity planning or covering the organizational side. Our main objectives of setting up a disaster recovery project is to minimize recovery points, minimize recovery times, and give you optimal recovery consistency. So behind those points are how much data would you lose in case of a disaster. And again, disaster recovery, no matter how you set it up, there always is going to be a certain amount of data loss. What we want to do is we want to minimize it. And the reason I say there always has to be, if you have large distances between a source system and a target system, even 200 or 300 miles, which even is not that much, you're always going to have a delay in synchronizing data to the target site, and you're always going to lose a certain amount of data. If you try to synchronize data between 2 data centers and keep source and target identical at any time, you're always going to slow down your production system. And that's, for us, 99% of the cases, a disaster recovery project has to expect a certain amount of data loss. We want to minimize it, but it's going to be there. Same with the recovery times, what you see on the right-hand side. How long is it going to take us to be up and running on our disaster recovery system or disaster recovery systems? If it's one single server, it's quicker. If it's a complete server farm, let's say 60, 70 servers, which have to be brought up, there's a certain amount of time we have to give ourselves to bring the system up. And I want to go back to the difference between high availability and disaster recovery. What we scope a DR project for is for the worst case scenario, which means your production data center disappears. We have potentially an earthquake or a hurricane, or the building is burning down. We are not preparing for a storage system that fails, or a CPU that goes bad, or items like that. We are really preparing for the worst case scenario. The third objective, and we have been working actively with this one for a couple of years now is to think about a complex landscape with multiple systems. If you have asynchronous replication, some systems might be ahead of other systems in terms of replication. What we are wanting to achieve is to give a recovery consistency point to say, I have 50 servers and I want to synchronize those servers to the same timestamp versus just recover every server to the latest recovery point. So we're taking recovery points and combine them with recovery consistency points, and I show you later in the presentation how we do that. I put some thoughts together how I perceive or how we perceive as a company disaster recovery. We have been involved in many disaster recovery projects. Not all of them wind up using the Libelle software. Some didn't implement VR at all. Some were looking at other tools. When I look at the disaster recovery readiness, there are some severe structural deficiencies when we look at how large organizations and even some of the biggest organizations are handling disaster recovery. The worst case scenario, 99% of the cases, it's never going to happen. So there is no real impact of having insufficient DR, but we have to think about if something is happening, what is the extent of the impact? How am I going to continue running my business? And if you go through down to the chain of command, down to the very basis and ask the people on the basis, how good is my disaster recovery? You usually get the honest answer that it is typically not in very good shape. And that's just something I want to pass out. It's up to each organization to look at that. But from what I see, it's not looking good. Next, I want to talk about replication strategies. And this is the question on what technology or what methodology am I using to replicate data. I believe pretty much all tools fall into one or the other category in this environment. Backup and restore is technically not replication, but I still fit it in there because many customers simply have an agreement with a provider where they ship tapes and then they just restore their application from tapes. That just put that in quotation marks, because if you think about a 30-40 system landscape, building that from tape, it's going to be taking a while. The main categories are either block-based, flat file-based, or log file-based replication. Any block-based replication, and that includes storage replication, SAN replication, VMware replication. For example, the Site Recovery Manager is a block-based replication. We're looking at a storage volume as a virtual machine which is replicated. Flat file-based replication. It's not really a standalone strategy, but some customers have critical flat files which they use, for example, rsync for, or just any kind of a file copy tool. And then log file based is the strategy of building standby databases, which we are a firm believer in, and maintaining standby databases and operate on a database level for replication. What we as Libelle are doing, we are combining log file based replication for the database with flat file based replication for non-database files and trying to eliminate the disadvantages of both. So a lot of the items what you see in Libelle, some of that is log file based. We cover the flat files, and if you see Libelle, we fit basically in this log file and flat file based categories. One of the kind of architecture perspective we kept developing when we talk storage replication versus flat file replication versus database replication got me to a point to say we need to dissect systems and just look at the different components. And the title is all data equal? And the point, of course, is going to be not all data is equal. If you look at your application, that can be SAP, that can be any other application, it keeps critical change data in databases. The database keeps online logs and offline log files which are managed by the database and kept consistent at any time. And we call this the database layer. And then the database keeps their files as files in the file system. So if you look at an Oracle database with 50 terabytes, there's going to be 500 data files or 2,000 data files which are sitting somewhere on the storage and being accessed by the different aspects of the database. In addition, you have application binaries and you have critical files. So for example, application binaries would be the SAP executables, and the critical files could be the J2E directories. If you have EDI or anything other where you have interface data coming in, there would be flat files sitting in the file system, critical but not inside a database. Now, all of that is of course kept and managed on the storage, on a storage level replicate or storage level area. And when you now think about replication, where do you want to replicate? On a storage level or on an application level or on a database level? And the point I want to make is if you do synchronous replication for high availability, none of that matters because you have an identical system. If you do asynchronous replication, every single component in that diagram matters because none of that is ever going to be consistent because storage blocks make up files, files make up databases, databases make up applications. So the point I want to drive home is Libelle replicates on a database layer. We do include all the application flat files, and we believe that this is basically guaranteeing data integrity. Asynchronous block-based replication is only ensuring block-level consistency. And I see a lot of presentations and I always kind of look into, okay, how do we integrate, how do we guarantee database integrity? And the answer I get is, well, you do consistency points on the database. And if you do a restore or you bring up the systems on the target side, you use the database log files to get to a certain point in time. And I see this as a workaround and not as a strategy. If you have storage level replication, you don't have application level consistency. So the point is, not all data is equal. And we believe you really have to look at the moving parts within your systems. You have to separate the database from the files, and you cannot just mix it up all on the storage and let the storage do its things, because at the end, you have to bring up those systems on the target side. So much as an introduction to disaster recovery. There is much more you can think about in terms of architecture, but these are the 5 slides I want to drive home in terms of how we see disaster recovery, the readiness of companies for DR, the different strategies you can use, and then what I believe the main differences between a storage-based, flat file-based, and log file-based replication strategy is. I want to now introduce our tool, Libelle, for complete disaster recovery. And we are providing a software solution. It's called Business Shadow. And within that Business Shadow solution, we have 2 main components, a database replication tool and a flat file replication tool. Now, this database replication tool is now working with different databases. Either if you have, for example, all Oracle, it would be DB Shadow for all Oracle. If you have a mixed environment, which is often the case, I have one customer, he has SAP based on DB2, and then a couple of bolt-on applications, which are all Microsoft SQL Server. We would have a DB Shadow for Oracle and a second one for MS SQL Server. Same mechanism, but tying into a different database. And that DB Shadow is available for Oracle, for MaxDB, for DB2, Microsoft SQL Server. Since last year, we have this for Sybase, and I'm hoping sometimes this year, probably towards the end of this year, we're going to have this for the HANA DB. Second, the FS Shadow is now replicating flat files, and the flat file replication is looking at a file system, and we monitor file systems for file system changes, and then have a similar mechanism as a database archiving mechanism where we archive changes and then copy those archive files to a target system and then keep a mirror system or target system in recovery mode on the target side. The architecture now from a different perspective. Again, we have our production system, we have our mirror or target system or the R system. You have your database or databases, you have flat files. Our software operates on server agents, so there's going to be one agent on source, one agent on the target, which is communicating between source and target and communicating to a graphical user interface. Now, having said that, if you think about that you have an agent, that means that we expect a physical server which can hold that server agent. That server doesn't have to be the same size as the production system, but it has to be the same operating system, and we need the same disk space. After this is established, we have the server agents installed, we have a graphical user interface, we have 3 steps, one non-recurring step, which we call initial copy, or simply copy or initial sync, where you set up your mirror system and build it initially. And then we have 2 more processes which are continuous. One is called archiving, which is picking up change data from production and then shipping it to the target system. And then a recover process is managing the mirror system. The way it works specifically, the archiver process is picking up read or log files from the database, to use Oracle terms, or is doing backup of transaction logs, to use Microsoft SQL Server terms. Other databases have similar mechanisms, but our database archiver is always working with those log files, which are the backup and restore mechanisms of the database. The archiver for flat files, we look at the files, we have this archiver under our control and update the files on the target side. The recover process for the database is now keeping a standby database in recovery mode, so there is always going to be a database running on the target system in recovery, or in DB2 terms, roll forward recovery mode. If you think about the fact that there is a standby database already running, you basically know 24 by 7 that your disaster recovery system is ready to take over production at any time, because that database is running and it takes log files from production and actually updates that standby database. Log files can be very sensitive. If you have 5,000 log files over a week and there is one log file missing, that would break the sequence. That is also, however, important. You can never ever break the sequence to begin with because of your backup strategy on your production system. What I'm saying is this process, once it's up and running, is extremely reliable because you are using database mechanisms to keep your mirror system in sync, and that database is actively accepting log files from your production database. The architecture, and that's the last architecture slide before we get to more like not that this was uninteresting, but more like application of the architecture. So this is the last architecture slide. Our architecture is consistent across the different platforms, and that was one step which took us a long time to get to the point, but it was worth the effort because we now have one tool which operates across platforms in exactly or nearly exactly the same way. So we have an archiver running for Oracle. At the same time, we have an archiver running for XDB, and they are doing pretty much the same thing. If you want to do a point-in-time recovery on the target system, you use the same mechanisms across different platforms. And that also means you can mix Unix and Windows and use the same mechanisms and a centralized front-end interface. So the key and the core of the software is the server agents running on source, running on target, the graphical user interface, which we're going to look at in a couple of minutes in the live demo. And then you have the main processes, initial copy, the archiver on source, and the recover process on the target system. And you see in gray, once you are on the target system, you can actually run a copy in the opposite direction. You run archiver on the target and recover on your old source system, which is now, after the switch over, can become a target system. The structure process, I conveniently omitted this one, is critical for Oracle databases in particular, where we cover database changes which are not tracked in the log files. And that can be new data files, you move data files from one location to another, you add data files to your SAP, or you execute no logging transactions which are then updated with this structure process on the target system. I thought I was through with the architecture. I had one more slide which is showing you what is actually happening on the server. There's one process which is called TRD for Oracle, and then you see source system, target system, and the graphical user interface where everything comes together. Finally, we looked at a one single system architecture, and up to this point, once you set this up for one system, all you have to do is cascade this across your landscape, and that can be as many systems as you would like to cover. It could be 5, it could be 50. It does not make a difference. The graphical user interface front end, there is no physical limit on how many systems you can actually manage. Frank mentioned in the beginning that we have 8 out of the 50 Fortune 500 customers, and some of those customers are using this in a very high volume environment. So some of those databases are 10, 20 terabytes, and they produce 1 terabyte log files a day. So what we developed is a concept to say, what happens if there are more changes than my architecture can handle? And we developed this turbo archiving design to say, let's say there's an accumulation of log files, which can be based on transaction, it can be based on batch jobs, to say within 20 minutes I suddenly have 500 log files, which I usually don't have. So we can configure our software to say, well, as soon as you see logs accumulating, change your transfer mode from 1 file at a time to 10, 20, 30, or even 100 files at a time. And with that, you can get amazing performance results. We did one proof of concept in the past where this was even spread across multiple nodes on the database. So if you think about RAC, or if you think about DB2, DPF, where you have multiple nodes, you can combine this turbo archiving across a very large landscape, and we scale with the environment. The next concept I want to introduce is log queues. So we have this archiver process and a recover process. The archiver process is picking up changes pretty much in near real time. As soon as we see a log file, we copy it to the target system. On the target system, or on that mirror system, we queue up log files, for example, for 1 hour or 2 hours or even 4 hours. And that gives us room for doing point-in-time recoveries on the target system. So first of all, the mirror system, yes, it's 4 hours older, but it has all the changes to get to the same timestamp. I don't have to wait 4 hours for this to be current. If I don't want to, I can just change the time delay and get this current within a couple of minutes, or let's say 10 and 15 minutes, depending on the kind of log files which are in there. But let's say I have a disaster incident and I have 50 systems, and some of them may be ahead than others. This is the recovery consistency point I was mentioning in the beginning. With this time delay, I can now recover all the systems to the exact same timestamp. And this is a huge advantage if you think about how systems are interacting and how systems are connected. And sometimes for critical systems, it's more important to have systems in sync rather than have 2 more minutes worth of transactions in one system versus the other system. And then more a service concept we have been developing, looking at customers to say, in the beginning we were dissecting the application, but we also started to look at your environment and to think of, we have recovery points, you have recovery times. Now, which systems are more critical than other systems? And it depends on the customers if we really want to get that it's not even complex, but kind of putting systems into different categories to say, my interface data is more important than my supporting systems. And I need to get up my ECC system immediately. The BW system can be up a day later. And I can just prioritize both traffic, and I can prioritize resources to get systems up and running on the target side. I do a lot of bandwidth estimates, where we look at an SAP landscape, for example, and then what we typically see is, let's say you have 1 terabyte worth of log files every day from your SAP landscape. And what I typically see is that half of that bandwidth is used up by the BW system. Now, that might be all important, but the question is BW more important than my production planning system or my ECC system? And I always encourage customers to think about options of separating traffic according to the criticality of the application. On top of that, that BW system, traffic is, most of it is re-indexing of the database. It's not even change data, it's just internal optimization. So I'm not saying BW is unimportant, I'm just saying we might want to consider it as a separate category and keep BW outside the critical systems if it's not that critical. So I appreciate you following me through all these theoretical architecture slides. We now want to put this into reality by looking at the live demo. What I want to show you in the live demo, I want to show you how to set up systems, monitor systems, control systems, and do switchovers. In the setup interface, you're going to see me looking at this copy, archiving, structure, and recover options. I'm going to show you some of the mappings, notifications, and network settings. And I'm also going to show you how this is tying into Oracle versus Microsoft or DB2 and flat files. In the monitoring, I have a couple of systems in my landscape. We can look at a single system, we can look at the complete landscapes. I show you how we do messaging, auditing, that we basically document what happens for disaster recovery, and how all of that is visualized. In the control window, we're later going to see how to start and stop replication, how we can trigger fresh copies of the environment, and how we access the server configuration. And then the switch over, how can we activate the target system to make it a production or also for disaster recovery testing. So with that, I'm going to go to the graphical user interface, and before I forget, I encourage you again to ask questions during the presentation. If you saw anything earlier or if you see anything now which you would like to have more information about, use the Q&A feature in the webinar, and we can address that in the next in about 10 minutes when we are done with the live demo. What you see currently is the graphical user interface. It's a front end. You see this one just turned red, and I am aware of that. I'm going to show you later why, because that's a test system where we test a new feature. You see each box is representing one replication, and then we're later going to look into how this is specifically monitored. But before that, I want to show you the setup interface. This one is a database replication, DB Shadow for Oracle. And under the setup, we basically need to provide information on how we can access the database, how do we find the database binaries, what kind of directory am I using for the log files. And then well, here you say this is one of my colleagues' systems, do not touch. I promised him I'm not going to do anything, just going to show it. The main functions are copy, archiver, recover, and structure to set up the replication. And we can basically specify how we copy the database from source to target. We do all of that for you for all the different platforms. And you can basically say, how do I set up that initial sync? Next is archiving. And we can say, how do I configure this archiver process? How often should we pick up changes from the database if the database is not releasing any changes by itself. And this is set to 20 minutes. I can set this to 2 minutes or 5 minutes. However, I want to configure that. The number 10, where you see a number of parallel archiver processes, this is the turbo archiving feature I was mentioning earlier. The recover process is now showing you how to configure the time delay. This is currently set to 1 hour, so there's always going to be 1 hour worth of log files on the target side. Structure process is checking for structure changes. It can be enabled or disabled depending on how you want to handle it. Typically, it should be enabled. And then we have some specific features, which is directory mapping, user mapping, that different structures are on source versus on target. Flat files, I'm going to talk to later. The notifications, where you would get emails or we trigger SNMP traps in case something is going wrong, and then you set up the network interfaces that you, for example, have separate network cards you want to use for replication. This is the setup for Oracle. On the left side, you see all different configurations. So I set this one up for Oracle. I know the WM1. This is an SAP system based on Windows, MS SQL Server. So you have similar, a similar layout, but different mechanisms to communicate with the database. There is a DB2 database configured, there's a MaxDB configured, and you see on the left side there's a bunch of different systems configured. Now if I look into the monitoring interface and let me pick a DB2, I can go directly into the status of that specific environment. What I want to see is always the green color. If we see an error or a warning, we would notify you like this is not looking good. And we are replicating, in this case, from a QS Linux 1 server to a QS Linux 2 server. And you see there are 3 log files sitting in that log queue on the target, which is represented by the triangle. And that means that the target system is currently 3 log files behind. In this case, there is no traffic on the system. All the log files I'm getting is when I actually trigger a log switch, which is configured to be every 20 minutes. If you take 20 minutes for a log file, 60 minutes time delay gives you exactly to these 3 recover files. If you have different parameters, for example, the Microsoft SQL Server, this is a bit kind of reversed because this was already switched over to the target side. We are running now production on the target, use the old source as a target system. But to use the same example, we have 5 minutes log switch interval and we have a 60-minute time delay that makes 60 log files sitting in that queue. When you open the messages, you see either recover messages from the target system, which in this case is my old source system, or you see archiver messages from the source system, which in my case is subsub B2, which says, hey, I got a new log file, I'm going to copy that to the target side and wait for the next one. Those messages are looking pretty much identical across the landscape, so let me go back to the DB2 environment. So in case of this one, we have simply standard DB2 database logs which are recovered to the target side. And then if I pick the source system, he's copying the log files. This is configured to be in German, so all those messages say the same, just in German. And you can just change the language of the server process as well. So at any time you see the status, you want to see it in green. And one of the big steps we took in 2000, we started in 2005, but it took us until probably 2008 until we had it to this step, is the concept of managing multiple systems, that you see a landscape representing your complete environment and the replication status of all those different systems. So there's a single system view, a group view. So I put everything in one group called live demo, but you can split it up into, say, like each SAP application has a central instance server, which is flat files, a database server, which is DB Shadow, DB2, and maybe 2 application servers which are replicated, which is 4, goes into the group SAP at ECC. And then finally, I want to see a list view where we see the complete environment and the type of replication. So for example, if I sort by type, I have 4 DB2 databases, and these are all borrowed from my colleagues from our QS department, from my development department, and I asked them to set them up in a way that I can actually show them. So you have databases, DB2, you have MaxDB, you have Oracle, and you have Microsoft SQL Server. And then you see those yellow steady in between. Now, in the group view, they showed us green. The reason is there is no error on these, but we still show them yellow because in this case, there is no archiver and no recover running. That's why we keep showing it as, well, this looks good, but there is no replication going. That's why it shows us yellow. Now, the one system which keeps showing red is called QS, I'll find it, QS Dixie. So here we are running an FS Shadow. The FS Shadow generally is doing what DB Shadow is doing, except instead of replicating databases, we are replicating flat files. And what happens is that the FS Shadow is basically, and I'm stuttering right now because I just lost my VPN connection to my data center in Stuttgart. That's why all of that is going to turn blue, meaning no status, but I can keep going with what we see right now. So the FS Shadow is replicating flat files. So we go through the flat file list which is defined. So let's say I have user sub binaries or executables, and all of that is monitored. What we saw in this QS Dixie, we are building an archiver where we don't detect the changes, but the changes are provided by us from the application. And this is a new tool we are developing to say, instead of us detecting changes, the customer can provide us with a list of changes based on a different mechanism. So it's kind of an API we are testing, and our development is currently testing that, and this is one of the test systems I was setting up. So let me briefly reconnect to my VPN, and basically the fact that I lost my connection doesn't impact production. It simply means I have no idea what's going on in my data center, and I just reconnected to the VPN. You see everything blue, meaning no status, and now it comes back. He's building a connection to the different systems, and I'm going to get my steady back. So let me finish this point with the FS Shadow. So this is an SAP system based on Linux, and I have a couple of flat file directories I want to replicate. So I have, for example, J2E, SDM, the profiles, and the executables. We do something similar for the Windows system, but we have been doing it a bit more detailed for the Windows system in this demo. This, of course, is different path names. And here we have been saying, I want to include executables, globals, profiles, but I want to exclude my job logs, and I want to exclude the J2E. I don't know why we would exclude the J2E because this is important, but these are all test systems. But that job logs are excluded makes sense for some customers. Many times flat file traffic is 90% job logs and then only 10% change data. So some customers said, well, I don't need those job logs for disaster recovery. So this gives you a good opportunity to replicate and also exclude certain directories which are not critical for your business. So we went through the setup, we looked through the monitoring interface. The control interface is now giving you options to manage that replication. So for example, the main options is simply to say, well, can I stop archiving? Now, one of the things I did on this configuration is to say, well, not everybody having access to the GUI can do anything. So I put in a password on the server that I have to provide that password, and then the connection stays open for a couple of minutes. So I stop archiver. I had to provide my password to do so. And now he is going to set this archive status to stop. That means I don't ship new log files. I don't do log switches. I just don't touch production for a while for whatever reason. And then you see the message, archiver process is finished. I can do the same for the recover process and say, well, just go ahead and stop recovering. I need to back up the database. I need it consistent, shut it down, and don't do anything. And then you see the recover messages on the target system doing, basically stopping, not doing anything. And then when I'm done doing what I'm doing, I can simply start my archiving again and start my recover process. I can also go ahead and look behind the scenes of the server process. So what I want to show today is all GUI frontend because it looks much nicer, but there's a whole world of server processes and communication and shared memory going up on behind the scene. And you can see this one in this shared memory, which is the current configuration. And here you see all the technical parameters of my environment, in this case Oracle. If I do the same for the DB2 environment and say show shared memory, you see a similar architecture, but this is a DB shader for DB2 server agent, and the processes are all starting as TRDB2, and then you have the different parameters, very detailed, very technical, and probably too much to go into details now. And then finally, there is this...
Sorry to interrupt.
Yeah. Yeah.
There's one question maybe even just to address right now while you are still there in that screen, where it says when you stop archiving, are the changes still queued for when you start later?
Yes. So basically, when I stop the archiver, you're going to see log files accumulating in that rectangle. And I can stop archiving for a week. And just as long as I have those log files, which are standard database log files, that is good. So for example, we just had one customer. It takes him a week to build the secondary system because he has to kind of back up source to tape and then ship the tape with FedEx and then restore the tape. That took him a week to do so, and we just queued up log files for a week. And that can be on source. We can queue them up on the target, but all of that is not impacting the functionality of the process. All we have to have is disk space. Thanks, Frank. I want to show the INI, not that I want to show the details, but I want to show more behind the scenes. And this is giving you additional detailed parameters. So you saw in the history, we came a long way, and this software has a lot of specific features for specific situations, to say like archive wait or socket lengths or timeouts, which you can all configure in this INI setting. And there is a lot of database specific information. For example, DB2, you can say, what am I doing with file access, file pointer versus file handle? I honestly don't even know what the difference is, but there's a technical reason for that. Somebody requested it and it was being put in for a reason. Finally, switch over. And I'm sorry I'm running short on the time, but I think let's spend a couple of minutes on this switch over interface. So I built all of this to be ready for a disaster incident, and now we want to support you by helping you bringing up the target system. So switch over, the term is a bit misleading because what we mean is switch over, basically you activate the standby database. So if you do a test, you actually don't switch over, you simply activate it in isolation, for example. But in reality, this is a disaster recovery solution. If you activate the target system, we assume you want to quotation mark switch over. That's why we want to leave that term in there. You can say do a point-in-time recovery. So remember, we have this log queue of 1 hour, and we can say, let's just recover everything, but only until it's 1:55 now, only until 1:30. This is German time, so 1:30 would be 19:30. My production system, last log file was at 1945. My standby system is 1 hour older based on the time delay. And I can simply basically change that time to say, let's do that until 1930. And I can even automate it in the background to send that timestamp via command line interface to the other systems. I can also say, I don't care about this point in time. I want to recover everything to end of logs. That means we have 3 log files there. They're going to be recovered, start up the system. And we are starting up that system for you, by the way. It's not that you have to do that yourself. We are doing all the pre and post processing for the startup of the target system. Lossless switching is starting up the target system before we do a recover to end of logs plus pick up the online log files from the source system. That means it's lossless, switching without a loss, but it also requires access to the production system. So if it's a complete disaster incident where everything is gone, we couldn't do that. Finally, the define switch. That means I'm switching over from a target system, from a production to the target system. At the same time, I'm activating my old production system as a target. So it's basically changing roles. We call this defined switch because it has to be a defined procedure, meaning this is a planned switch over versus an unplanned switch over. After a defined switch, I can immediately recover log files in the opposite direction because we never break the log sequence. Logs are simply continued on the other server. And this defined switch is available for DB2, Oracle, Microsoft SQL Server, MaxDB. All platforms that are available are supporting this defined switch feature. With that, I am a bit short on time. I want to go back to the PowerPoint and basically start handing over to Frank for the Q&A session and spend a couple of more minutes on Q&A.
Thank you, Bernd. Thank you, Bernd. There was one question that you answered earlier before, and that same content, there are some more add-on questions. So the first question was, when you stop archiving, are the changes still queued for when you start later? That is something you answered with yes. There is an add-on question to this. Can you stop archiving for a source system DB recovery to avoid network spikes?
Yes. And that's basically to say, I do a BI indexing and that's going to produce my 500 gigabyte of log files. I don't want to impact ECC replication, so I'm just going to slow this down. What I would do instead is, we have this turbo archiving, but we can do 10 files at the same time. And I just can slow this down by just setting one parallel process instead of 10, and that basically slows it down as well. But I can do this in different ways, and we can also trigger this with a command line interface. Instead of clicking through the GUI, you can just send a shell command, say reduce log files from 10 to 1 at a time, or stop archiving. It's one simple shell command.
Okay, so the next question was, would it make more sense to do an initial or initialization instead? I think no, that doesn't make sense, right?
It does not, except we just have one new feature for the MaxDB where we do exactly that, but based out of a different reason, because the MaxDB sometimes is very intensive in transactions. So we sometimes for smaller databases just do a fresh initial copy. It depends on the situation. Generally, we believe just let the log files catch up. It's going to be faster than you might think.
Okay, thank you. And there are some couple of questions regarding licensing. One, for instance, if they are licensed or if the customer is licensed for instance, Oracle or DB2 database through SAP, do they need to license the standby system at the DR side as well?
No. It's basically, when you look at SAP, the licensing model says you have your production system and then you have 5 non-production systems like QA, development and testing, and the DR system standby just counts as another one of those non-production systems.
So these are all covered by SAP. You don't need to do any additional licensing for DB2, for instance, via IBM.
Yeah, I can't speak for SAP, but that's the common understanding in the way the licenses are set up through SAP, that you get your licenses through SAP and then they would cover multiple non-SAP systems.
Okay.
And non-production systems.
Non-production systems, right. Another question is, Can we read from standby database in recovery mode on a DB2 environment?
I know it's working for Oracle. I am not 100% sure if you can open DB2 in read-only. It depends on the context. You might want to be, the other option is you do a snapshot of the target system and then open it as read-write. It depends on the context.
Okay. Another question just came in. There's one customer here in that webinar that doesn't want to invest in hot standby application servers, but he wants to reuse his non-production servers instead. Is that easily supported?
Yes, and that's my favorite strategy because you don't really need a full server which is just sitting there idle. So you can just co-host QA and disaster recovery. And there are two ways to approach this. One is to simply virtualize everything. So you have one physical box and you have a virtual machine for QA, one for development and one for disaster recovery, all coexisting. And then if you have a disaster incident, you just start up the DR system. And then eventually shut down the VMs on the target system for non-DR. I saw customers actually doing the same thing in non-virtualized environments. It's also possible, but it's not separated as good as virtual machines, and it's actually easier in Unix than it is in Windows. You just have to, from an organization, separate your QA work from your disaster recovery work, that people don't say, oh, there is a database which looks like the one I could use, let me just open that. So you've got to separate that. But generally, yes, many customers do that.
Okay. Last question that I see here. What is the protection mode for Oracle databases?
I think the term points to the Oracle Data Guard setup. So in Oracle Data Guard, you have these different modes, which is full sync or half sync, or we don't operate on the Oracle log writer. We operate only on the reader log files. So basically, we have to separate between physical standby, what we are doing, and a logical standby, what is Oracle Data Guard for in the logical setup is doing. And we believe it gives you kind of higher recovery points, which is on the first look not good. But then if you look at your environment with a lot of applications and a lot of databases and a lot of traffic, you wind up doing offline logs anyways. So this is the difference between physical standby and logical standby. We are doing physical standby.
Okay, perfect. I think these are all the questions that I can see on my screen. If there's no more coming in, I would like to say thank you very much, Bernd, for going through these questions. Thank you for your presentation, and also to the audience, thank you very much for your attention, for your interest today. I hope it was of interest for you and you took something out of it. Let us know if you're interested in a follow-up session or in a test installation. We are more than happy to schedule a new one-to-one webinar with you guys, or even if you want to proceed, we can also do test installations if you like, just to get a better understanding and feeling of how our tool is working and how well it fits into your environment. So thank you very much again. Have a nice afternoon and looking forward to see you tomorrow for the next webcast, Libelle System Copy Automation. Thank you very much. Good night. Good afternoon.